Brian Bodke. I'm endowed chair and professor at the University of Kentucky in the Department of Special Education and Rehabilitation Counseling. When we think of concrete representations, a lot of times we think about math because math teachers use in the elementary grades Cuisenaire rods and so forth. But concrete representations can be used in other areas as well, such as simulations, computer simulations now, for example, but also simulations, group activities in social studies and history. Concrete representations are very important and can be used across a number of content areas. We use in our research, just recently, we've used fraction strips where we say to the students, and these were 8th grade students, we give each student 4 long paper strips, and we say that those strips are representative of candy bars. So take one strip and say you have to divide your strip into 2 pieces, and how would you do that? So they fold the strip in half, and they label the first crease 1/2 and the second crease 2/2. And then they go on and they say, okay, take your second strip and divide that into 4. Pretend that you have to give a piece to each of 4 friends. How would you do that? So they fold the paper strip in half, and then they fold it again and label the creases 1/4, 2/4, 3/4, and 4/4. And they do the same for 8ths, and they do the same for 16ths. And then at the end of this exercise, the teacher asked the students, what did you notice about the size of the denominator as we folded the strips? And what they will say, of course, is that even though the number 16, for example, and 16ths is very large, the size, the actual size, the quantity of the candy bar that they're receiving is very small. So you can use those fraction strips to represent equivalent fractions, adding, subtracting fractions. One of the primary reasons for using concrete representations is to help students build mental models or pictures of what it is they're learning. For example, with the fraction strips, they're learning that if you divide a fraction strip into 4 pieces, those are 4ths. Obviously, we can't use concrete representations all the time, and that eventually we're going to have to move to the abstract so that students don't think that fractions are only used with candy bars or only used with linear measurement. So we will have to eventually move from the concrete to the abstract, but I guess the point is that the students, many students need to have a firm foundation in the concrete before they move to the abstract. One of the ways we've tried to connect the abstract or concrete to the abstract is both in computer simulation and in actual hands-on is with one of the adventures of Jasper Woodbury called Kim's Comet. That these are 10 to 12 minute video scenarios where the students try to figure out how to help the people in the video solve their math problem. Kim's Comet is one of the problems that I really like because it teaches pre-algebraic concepts such as line of best fit, function, variables, formulas, graphing, those types of skills. So the object of this particular problem is to help Kim, for the students to help Kim figure out where on a ramp to release her car to be able to be going a certain speed at the end of the ramp to negotiate several tricks, 5 different tricks. And students time their cars, figure out rate, graph the rates, and then based on their graph, they're able to predict where they should release the car to navigate each of the tricks. The speeds for navigating the tricks aren't given to the students until the end. And so the day of the Grand Pentathlon, as it's called, is very exciting for students because they use their own cars that they've built and they release them at certain heights on the ramp where they think their car will navigate the trick at the end of the ramp. The students learn a lot about pretty sophisticated math concepts. I want to emphasize that this project isn't just fun for the kids, it isn't just motivating for the kids. They also learn a lot about variables, they learn about measurement error, they learn about reliability, they learn how to figure out the relationship between distance, time. They're able to predict using their graphs, speeds, how to label x-axis, y-axis, and what that means. So there are a lot of concepts that are packed into this teaching unit that are not taught individually. They're taught in a meaningful way, much like you would encounter them in real life.